So this is just an introduction of some of the basic properties of logarithms. And I'm going to start off with the definition of a logarithm. And because logarithms and exponentials are so closely related, they're inverses of each other, the definition of a logarithm kind of depends on the definition of an exponential. So if we have some exponential where a equals b to the c power, then what that means is the logarithm base b of a equals c. And in this case, a, b, and c all mean the same thing. A is the argument, b is the base, and c is the exponent. Okay, so this is the definition of logarithms. And there's a whole bunch of rules about logs that spring out of this definition right here. For example, we know that any number to the 0th power equals 1. And we also know that any number to the 1th power equals that number. So I can turn both of these things into logarithmic expressions and say log b of 1 equals 0, and log base b of b equals 1, right? If you look at these equations right here and try to think of them backwards, going back to exponentials, we would say b to the 1 equals b, or b to the 0 equals 1. Okay, that's the way these work. So these rules that I just wrote here are sometimes referred to as the 1 and 0 rules, but it's not really important to remember the name as long as you remember what they are. There's another set of assumptions, not really assumptions, it's an unwritten rule. They're called unwritten bases. Sometimes you'll see a log without that b written under it. For example, it'll just be log of a number, right? It'll just say log of argument, but it doesn't say what the b is. And when you see something like this, it just means log base 10 of a. And the reason for that is just because 10 is a very common exponent, so we don't write it. Another one that's very common is to see this ln. What that means, this is called the natural log. Okay, natural logarithm. So what that ln means, it's also a log, but it's a base of e. And if you haven't run into e before, e is a very special number of 2.71, and it goes on for a while. I can't remember what comes next, maybe 2, 8, something like that. Sort of like pi is a special number, right? Pi is 3.14, and it goes on for a while. So e is so special that mathematicians made a logarithm just for it. It's called the natural log. But what it is it's just log base e. All right, another very important formula, you'll use this one a lot, is the change of base formula. It's called change of base formula. And what this is mostly used for is when you have a calculator that doesn't know how to do log base of something. Like if I had log of 7 of some number, a lot of calculators don't know how to deal with that 7. All they have is a log button. So I'm just going to call this log base b of a. The change of base formula says you can just turn that into log of a divided by log of b. Okay, and in this case, when I say log, I mean that log base 10 that all calculators know how to do. Okay, moving along. There's an inverse property of logs, which I think we've talked about before. Inverse, I'll just call this the inverse rule. And what this means is, this gets back to the fact that logarithms and exponents are inverses of each other. So if I have an exponential like this, and I put that exponential inside a logarithm, okay, the logarithm undoes the exponential. They cancel each other out, and all you get is that c left, right? You can think of it as log cancels out the exponent. It's not exactly what's going on, but it's a decent enough way to remember it. And likewise, if you have an exponential that itself is a logarithm, I gotta be careful how I write this one. If I have a logarithm, okay, log base b of a, and I put that inside an exponential, okay, b raised to this power, b raised to the power of logarithm, then, just like before, the exponent and the logarithm cancel each other out. So you can think of it as if that b and the log b are canceling out, and you just have the a left. And the last set, this is the new ones that we're getting into and some of the most useful. These are called product rules. And what's another one? Another one is called the quotient rule. I don't need this much space. They're really not that big. Let's put these a little closer together. And the last one is called the power rule. Okay, you have these three rules, and these are some of the most frequently used rules of logarithms, and they're pretty simple. If I have the logarithm, I'm going to stop writing base b. Okay, just assume I mean base b. The logarithm of x times y equals logarithm of x plus logarithm of y. Okay, that's the product rule. And the quotient rule is similar to it. If I have the logarithm of x divided by y, that's equal to the logarithm of x minus the logarithm of y. And the last one is the power rule. If I have the logarithm of x to the n power, then that's equal to n times the logarithm of x. Okay, you just bring that exponent out and you use it as a multiplier. Now, we went over the derivation of these in class. We're not going to go over those now. It takes a little while to work through. But you can use these anytime you see a logarithm with some kind of a fraction in it or a product of things. You can expand those out into something bigger that has simpler arguments. Or, going the other way, you could take something that's maybe a couple of logarithms added together and condense it into one logarithm with a more complicated argument. And there's reasons why you might want to do both. Usually has to do with equations. But those are all your major properties of logarithms.